Okay, so now I'd like to go forward and start. So today we are going to do light. So yeah, all right. So about light, first we're gonna learn what exactly is light. Light is a transverse wave. You guys should remember this value, that speed of light in air or vacuum is denoted by C, and it is 3.0 times 10 raised to 8 meters per second. Then obviously light can travel in vacuum as well. So just like reflection happens in general waves, so light follows the same rules of all reflection, refraction and diffraction, everything the same. So we're gonna basically go towards the reflection of light on a plane mirror and learn how to draw this with scale as well, because they might ask you to do this. So I'm going to take a screenshot here and see what we can do about it. So the first thing you guys should do is, okay, where is my ruler? That's not fair. Oh, it was there. Ruler, come out. It is gone. Oh wait, I don't know how to bring it back. Wait, ruler. Oh no, that's not fair. Wait a second. Let me open it again. Take the screenshot. Where is my ruler? Oh no, it's gone somewhere. Okay, let me try with this. Okay, it's not working. That's not fair. I was supposed to do it with a ruler, but now I cannot. Anyway, what to do then? Let me see if I can take screenshot from the other app. It's right there in the corner, but oh holy, I guess I need a restart for this. I don't know why it's gone down like this and now it's not coming up. Oh, it has. It moved, thank God. Alright, now ruler is here. Okay, so now that we have a ruler back, so we're gonna first draw, like you can draw any wave from any angle, it's up to you, it doesn't really matter. So I'm gonna draw the first from the arrowhead to this point, and then I'm gonna make a 90-degree normal here. So you can use another color. Okay, when you draw the normal, obviously from the normal we can measure this angle, and this angle is exactly 35 degrees, which, second please, just realize it. Okay, so which means that this angle got to be 35 degrees, and because we're following the laws of reflection here, so we're gonna make, like, reflect the ray back at 35 degrees. So we're gonna take 35 degrees from here, and then it's gonna reflect like this. So this would be R ray, and angle of reflection is 35 as well. Do you guys understand this? And then make arrows, like it goes here, it goes here. Any questions, please let me know. Now once you've done this, then you have to take another line from the same point at any other angle you like, it doesn't really matter. So I'm going to take it at 52, change the color, it's green. Oh, not this one, this one. Okay, wait a second. Yeah, so I'm going to take another line from the same point and I'm going to take it here. And then you got to make normal again at the same point where it strikes. Okay, so draw normal. Okay, who's this weapon? Can you introduce yourself, please? So this angle was basically 52, so I'm gonna draw 52, and then I have to take like the same angle, like same 52 degrees, and using protractor, and then from here we're gonna make the same line like this, and that's gonna be 52 degrees as well, right? And draw arrows. So once you've done two angles, two of these rays, and you might see they're basically diverging from the eye. So if they do not meet on our eye, it would mean that those two lines, the eye would think are coming from behind the mirror. Okay, which essentially means that now you just need to extend them backwards, extend them, and then also the other one, where they meet, that would be the point where that arrow or the image is going to be formed. So if this is your object, that will be the point where image is formed. And this section that you see right now, this section, you guys need to, it's called extrapolate this, because in this section it means that this is like your eyes think they're coming from behind the mirror, which is not real, but it just seems like that, although they're reflecting from the mirror. Okay,
so what is it again?
sorry, come again.
Is it extrapolate this?
Extrapolate the two lines. All right, let me just write it clearly. I'll write it on the PDF. Wait, I hope you guys at least understand this, right? That how I created this image, which is basically required. I'm going to delete this, put it back here, paste. Okay, all right. Okay, like that, right? So now this section that we know, this section, these two lines, as you can see, you need to extrapolate the two rays backwards, and image is formed where the rays meet. Is it clear?
Yes, sir.
Saifullah, is this your first class? Saif? Now, the properties of mirror are number one. You always need to remember that the image is virtual. Virtual means that it is not formed on the screen. It's basically formed behind the screen, which is not real because there's nothing, there's just wall there, right? Number two, image is same size as of object. Number three, image is same distance from the mirror as of object, which means is that this distance, like if this distance is suppose d, then from the mirror this is also d. And you also know that you might have noticed that when you're standing in front of the mirror, and this is the mirror, you look yourself here, so the image is also the same way. And if you come closer to the mirror and touch your finger, the image also comes closer and touches the finger. So it basically always the same distance from the mirror as the object is. Is it clear?
Yes, sir.
Alright. Yusra and Caroline, Zainab, Kazim, Shawiz, Fatma. No. Right.
Yes, sir.
Then the fourth one is that the image is laterally inverted. Laterally inverted means that letter P would look like this, letter S would look like this. Do you guys understand? So it's like horizontally flipped. Alright, is it clear? Now,
Sir, can you move up a little bit?
yes, please. Here.
Okay, that's it.
Alright, very nice. Okay, so then looking at the first question, it says an object is placed before a plane mirror as shown. A student views the image of the object in the mirror from point P. Alright, so the object is here and the student views from here. So it says where does she see the image? Obviously, if the object is here and if you see this, wherever the object is, the image will be directly in front of it. Alright, which means that D has to be the correct answer because that would make the same distance and the same, place. Is it clear? So object, I'm just writing, note object and image are always same distance apart from mirror, directly in front of each other. So you guys need to remember that. Alright, any questions, please let me know. Okay, now then the next question is of this one, and you guys can actually answer this on your own because this is a very similar question, so that's a homework. then go forward. Okay, for this one, it says a card is placed in front of mirror, so the label is facing the mirror as shown. How does the image appear? So basically, you got to flip the image horizontally, which means I would come first and C would be flipped like this, right? So I think that would be C. Is it clear, everyone? So you just flip the whole thing horizontally. Right. Now, this question is a very important question. And it says a student uses one eye to look at the image and says which objects give rise to images that can be seen by the mirror. All right. So the maximum I can see is at the edge of the mirror, and that's when, if this is your angle I, so at the same angle you can go here R. So you can't see U, you can't see Y. And then on this side as well, like if you draw an arrow like this, so this would be your angle I, and obviously I think it should be almost here, right? So you can use a protractor to do it accurately. So sorry, this is R and I and R. So you can't see, like you can see Q, you can see R, you can see E, S, T, but you can't see U and P. So Q, R, S, T only, and you can't see P and U. Is it clear? So the farthest I can see from the edge of mirror. Beyond that, you cannot see. Okay, that's how it works. All right, any questions? Please let me know. Interesting. All right. Now we're gonna go to the next question, and Snell's law. So before we head further, we just need to know what is the Snell's law. Snell's law basically tells you about refraction, and let's write about it. Okay. So Snell's law basically says it is the ratio of speed of a wave in two different mediums. Luckily, one of the mediums in our will be just air. So the symbol of this is N, where N is called the refractive index. So N has two formulas. The first formula is the speed of light in air or vacuum, that you already know is 3.0 times 10 raised to 8, divided by the speed of light in a medium. It could be any transparent medium like water, glass, diamond, whatever. So in short, we remember this formula by N equals to C over V, where C is the speed of light in air and V is the speed of light in any medium. The other formula for Snell's law is given by sine of angle of incidence divided by sine of angle of refraction. And obviously you can remember this. I'm just going to write this here, where I is the angle of incidence and R is the angle of refraction. Okay, please write this down. Okay, now refractive index of some of the common values like air is just 1. You don't need to remember the values. Glass is 1.5 and diamond is 2.4. So if you go down, you might see that as the density increases, the refractive index also increases. So we're gonna learn this, that higher the density, greater the refractive index, which means this material, the higher the density material, it will obviously refract more than the lower one. Okay, is it clear?
Yes.
Okay, please everybody write this, and then we're gonna go forward. Okay. So then we're going to look at the refraction of light. First of all, we're going to look at the middle figure. So suppose a ray of light is entering. Oh, it should be straight. That's not fair. Okay, suppose you don't have to remember anything, cause I've just given you to show the trend. That's it. Okay. So suppose a ray of light is incident here. So again, the same rules. You're gonna make a normal line at this point. This will be your angle I, and this ray, because it's going from air to glass, it's more dense, so it's gonna bend towards the normal, like this. Same rules like you've studied before. It's R, and then obviously you're gonna make a normal line again. So this will be I now, and when it goes back to the air, it's gonna go like this, which is R as well. All right, is it clear, everyone? Now, when it goes like this, I just want to tell you two things. If light comes directly straight like this, and the normal line and the ray is parallel, then this ray basically goes undeviated. It doesn't make any angle, right? So we can say that, I'm going to make normal again, it got vanished. Light goes undeviated if it's parallel to normal line. So you guys need to remember this, okay? And because circle has all points like act as a normal, so if the light enters into a circle, it would just go straight anywhere, like that, okay?
So you can say that if it is parallel to the normal line or perpendicular to the circle, right?
Yes, you can say that. Perpendicular, it would be the same thing, okay? Now the same rules apply in both the cases. Like this case is when it is going from less dense to more dense, and this is this, so we're gonna write about them. So in the first one, when it's going from less dense to more dense, so light bends towards normal and angle I is greater than angle R. The third thing you guys should remember, speed of light decreases, and the fourth thing, wavelength decreases. Also, when it's going from a more dense to a less dense material, then light bends away from normal, then angle I is less than angle R. So that's the same thing we've studied before, alright? Because this is also wave, and the speed of light increases. And the fourth thing is that wavelength increases as well. The only thing that remains same, right? Frequency remains the same in both the cases. Alright, is it clear?
So I have a question.
Yes.
Why does frequency remain the same?
Because the number of waves that enter into the medium are the same number of waves that exit the medium. That's why. You get it?
Okay, that's easier to absorb.
Okay, yeah. And then about Snell's law, I just want to tell you, and I'm going to write in different colors so you guys remember this. Oh, this doesn't seem very different. I'm going to use hello. Guys, give me like 2 minutes. Hello. 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 All right. So now let's talk about it a bit more. So about this, you guys should remember that when the light is going from, say, this more dense, less dense to more dense, then you're gonna use n equals to sine I over sine R as your formula. Okay, so I'm gonna put it here to make it easier. And if you notice, everything that happens in like less dense to more dense, that is opposite in dense to less dense, which means that when you're using Snell's law, you have to use sine I over sine R equals to 1 upon n. And why are we taking the reciprocal? Because whatever happens here is exact opposite. That is the reason we are also taking reciprocal there. Is it clear, everyone?
Yes, so the N is the refractive index of the lower plates.
N is the refractive index where, let me write, where N is the refractive index of medium. Like in this one, it is for glass maybe, right? Or it could be some other medium, water, whatever. Do you understand?
Yes. Yes.
Okay, so this is how you can find the angles. You can write this down and then we'll look at some of the questions, how to, deal with this. So remember the formula for less to more dense, and always take a reciprocal if it's the opposite. That will help you, figure out quickly. Okay, then. Pretty good. Now, so going to the next part. I hope you guys have written this and drawn. Okay, so going to the next part. So in this one it says light has a speed of this in diamond. What is the refractive index of diamond? So we can simply do this like this. We can say n is the speed of light in air over speed of light in diamond. So speed of light in air is 3.0 times 10 raised to power 8, and diamond is 1.24 times 10 raised to power 8. Can you guys help me find this? It should be 2.42.
Yes, sir.
Yeah, I know this because I have learned this, all right? But you don't need to learn this. You can obviously use the formula to do that. All right. Is it clear, everyone? Should I go forward now? Now, in this one, it says a narrow beam of light is traveling through transparent block and meets the surface shown. An angle of incidence is 40. Now, because it's going from liquid to air, so it's going from less dense, like more dense to less dense. So it means I'm gonna use sine I over sine of R equals to 1 upon n. So sine I will be 40. I gotta use to find R, and I'm gonna use refractive index like 1 upon n. This is 1.5, so I'm gonna use this. Now, how do you find this? Obviously, it will be sine R equals to 1.5 times sine of 40, and then we have to take the inverse of sine. So if you don't know how to do that, let me show you this. So generally what you do is you write 1.5 times sine of 40, and then you take shift, you press sine, it will give you sine inverse, and you can put the answer inside. And now R is going to be 75 degrees, which is this answer. All right, is it clear, everyone?
Sir, can you explain the last question again?
This one,
Yes, sir.
you just need to use this formula like I told you. The formula is the speed of light in air over speed of light in any medium. Right now we have diamond, so I put speed of light air here and the speed of light in diamond here. So when you divided it, we got n. You get it?
Yes, sir.
Then this would be the question that is very important, right? So currently they've shown that when air and dilute sugar is given, like 60 and 40 angle is like bends to 40. If you send like light from air at 60, but if the concentrated solution is there, then the angle is different, which means that the higher the density is, the greater the refraction is going to happen, right? So refractive index of as concentration increases, does it increase or decrease? What do you guys say?
Increase.
Increases because density is increasing. And speed through solution concentration increases. So the speed increases or decreases?
Decreases.
Decreases. Because if it's more dense, obviously light will have trouble going through it, which means speed decreases. That has to be C. Okay, any questions now? Let me know. Zainab, Smiley, and Caroline.
Sir, why is it C?
Because as the density is going to increase, obviously refractive index is going to be higher, and the higher density it is, the greater, like this lesser the speed is going to be, because in more dense it has to, it will be slower as it's spending more. Do you understand? So imagine if you want to, like if you swim in water, it's easier because density is less. But if I ask you to swim in honey, it would be difficult, right? Same goes for light. Is it there?
Yes, sir.
That analogy is like from a different thing, but I just wanted to explain. It doesn't, refer to light in general. Anyway, so now this question is a very simple question. You just need to do this as homework. But I'd like to do this question, which is very, very important. Now, this is a new type of question. They say show that light approaching the boundary between two material. It shows that light is approaching with the speed of v. Right now the speed is v, and says the speed of light after crossing the boundary is 1.3 v, right? So it means speed of light is v, and the speed after that is 1.3 v. Okay, so it says determine the angle of incidence. Okay, now obviously you got to make a normal line, and because this is 90 degrees, so 50 minus 90 will be 40 degrees, so that's why it is just one mark. And then says the angle of refraction. Now what to do? Now we do not have the refractive index, but we know refractive index is given by speed of light in air divided by speed of light in any medium. So that is v, and now right now the medium has 1.3 v, like that. So v and v will cancel out, so n will be 1 upon 1.3. Can you guys get me the answer, please?
Zero point 769.
Oh, sorry, it's not exactly correct. It's going from more dense to less dense, so you have to take 1 upon n. Sorry. Speed in medium 1, speed in medium 2. There's no air actually. So it's going to be 1 upon 1.3. So n will be 1.3. You agree?
Sir.
Yes. Okay, I'll explain it again. So there's no air. Sorry, my bad. There was no air. There's something else here. So there are two boundaries. So it's saying that because how do I know it's going to bend outwards? Because the speed is higher. If the speed was higher afterwards, it means it is going from more dense to less dense. This is why it is a difficult question. So which means that speed in one medium over speed in the second medium has to be 1 upon n, because it's going in the opposite direction. That doesn't apply to air and that, because that's self understood. Now in the speed of the first medium was v, and the speed in the second medium was 3v, and v will cancel out, so it will be 1 upon 1.3 equals to 1 upon n. So n then will be 1.3. Is it clear?
Yes.
Now originally when I did the wrong thing, like I did n equals to 1 over 1.3, and Imal, what was the answer?
0.76.
0.76. Now how did I know this was wrong? Okay, because the minimum refractive index is 1, and that is in air or vacuum. Do you guys understand this? So any value of n less than 1 would be wrong. That's why I thought, oh, let me check my work again. Do you guys understand? That's just a tip to know. That's why I've written those things for you. Is it clear? Okay, now that we have refractive index, we want to find angle of refraction. So we're going to use the other formula. Sine I over sine R, because it's going from more dense to less dense, so 1 upon n. So sine of I is 40 degrees. Sine of R we need, and that's going to be 1 upon 1.3. So sine 40 times 1.3 equals to sine of R. Can you please find R for me? .6, which means 57 degrees. Okay, very nice. Any questions now? Please let me know. Cool. All right.
Sir, can you explain the writing that is in blue?
Yeah. So I'll write it down neatly. Wait. So I said that how did I know I made a mistake? All right. So refractive index n cannot be less than 1, which is in air or vacuum. Do you understand? So, if you get any answer of n less than 1, it means you have made a mistake. Is it clear, Himal?
No, so can you explain further?
Sorry, come again?
Sir, I didn't get it.
Okay. When I wrote this here, like I said, air has just one refractive index, right? Air is the least dense thing. Do you understand? And vacuum has no density at all because vacuum has no mass. So what I'm saying is that you cannot go below, n cannot be below 1. Do you get my point?
Yes, sir.
So if you get a value of n in any of your answers less than 1, it means you have made a mistake. You should revisit that question again. You get it?
Yes, I got it.
Okay, good. Now let's go forward now to this one. Okay, so this question basically is sort of a question where you need to do a little bit of construction, and I'm going to help you with this. And then we're going to talk about the other things. Okay, so let me put it, take a screenshot. So in this one, it says on figure, draw accurately the path of the ray within the prism AB to face AC. Okay, that's what you're going to do. So, and the refractive index is 1.5. So first of all, I'm gonna use my protractor and I'm gonna put it right here, and I'm gonna measure 90 degrees so that I know exactly what I know exactly where the normal is. So this is my normal line, and then I'm gonna measure the angle. So this was like at 45 degrees, and if I measure the angle here, this is like 15. So 45 minus 15 is basically 30 degrees. So it means this angle right here is 30 degrees. Oh no, it's not 30, sorry, wait a second. So from this angle to this angle, that's basically sort of 45 minus 15, so this angle is 30 degrees. So in your, because you will have a different protractor, obviously it will be easier for you, and this is going to be 60 degrees. So angle I is 60 degrees. Now because I got angle I, now I want to find angle R, and I can use, because it's going from less dense to more dense, I can use sine I over sine R equals to n. Sine I is 60, sine R is R, and n is 1.5. Can you find R, please? Yes, please, go on. Give me an answer.
35.3.
35.3. Okay, so we got 35 degrees. So we're gonna now measure 35 degrees. Okay, 35 degrees. On my in this one, it's very hard for me. Okay, so bear with me. So if this is like, this is 9, this is 90, and I'm gonna go 35 degrees from here. Okay, no, 35 degrees would be not this one, sorry, it's harder for me. 40 till 15. Okay, somewhat like this here. All right. So this angle will be 35 degrees, and you're going to draw the line like this, and just goes like this, and this angle would be 35 degrees that you need to draw. Because you have a protractor, so you can put the protractor like this and then measure 35 from the normal line. It would be easier for you, but my is the digital one, so it takes a reference from horizontal. That's fine. So this would be how you would draw this. All right. Now I'm going to put it back to where it belongs. Perfect. Here. Okay. All right. So right here. Fair enough. So we got AC right here. Now it says later on determine the angle of incidence on face AC. You need to basically again draw a normal line here and then measure the angle. You can do the rest of the things yourself. So all these parts, the next one, are homework. Okay. Now going to, if you have questions, please let me know. Otherwise, I'd like to go forward. Okay. Then we are going to go to the critical angle. Now, critical angle is defined as an angle of incidence, I, angle of incidence, let's just write angle of incidence where the refracted ray bends 90 degrees to normal, like this, right? So what it means is, the symbol we use for critical angle is capital C. The formula is sine C equals to 1 upon n. That is the refractive index. So let's look at it. For example, suppose a ray was coming into glass like this. So this is glass. So just to show you that it's more dense. So normally what would happen is this, if the angle of incidence is less than the critical angle, then this ray would bend like we know normally it does. This would be R. But when the angle of incidence is increased to a certain point where now angle of incidence is equal to critical angle, that's when the ray is going to go like this, which basically means that the refractive index, the angle of refraction is going to be 90 degrees. Do you guys understand this? And if
Yes.
ray is further increased, which means that now the angle of incidence is greater than the critical angle, then what happens is that the ray would actually bend inside or reflect inside, and this phenomena is known as total internal reflection. All right. Just like that. Now give me a second, please. Now, so total internal reflection is basically a phenomena best known as, let me write it down, that when the angle of incidence I becomes greater than critical angle, sorry, moving from a more dense medium to less dense, and that's very important, right? It reflects back inside. This phenomenon is known as total internal reflection. Is it clear, everyone? Cool. Now, we're gonna basically look at some of the questions from total internal reflection and understand how it helps us in a lot of ways. If you've written it, I want to go forward. Now, so for example, in this question, it says, what is the refractive index of the glass? Now, yes, okay, sorry. Okay then, done. Should I go forward now?
Yes.
Okay. So, in case that this happens, okay, and for example, we know that this is like normal reflection, this is where the critical angle is, this is total internal reflection. So we can always find refractive index using critical angle, because we know that critical angle is sine c equals to 1 upon n, and obviously this is the angle c, because it is when 90-degree refraction happens. We're going to write sine of 44 equals to 1 upon n. Can you find n, please?
It's B.
It's D. Okay.
It's B.
Okay. Very nice. All right. Very nice.
No,
Very nice.
no, it's a B.
It's B.
Yeah.
Okay, B then. All right. So this is very simple. You just need to use critical angle in this. Now it says that the diagram shows ray of light in air incident. Some light is refracted, some light is reflected. Two angles PQ are marked on this. Which row gives the angle of incidence and states whether total internal reflection occurs? Now, so first of all, you need to understand that the angle of incidence got to be Q, because that's where the light is. But because it is going from air to glass, so no total internal reflection occurs. The reason is because for total internal reflection, it's only possible, right? It is only possible when light is moving from more dense to less dense. Right now, the light is moving from less dense to more dense, so that's not possible. Is it clear?
Also, sir, some of the rays are also reflecting, so not due to internal reflection.
No, it could be possibility that there could be a partial reflection. We're gonna study that in next class, but right now it's not possible in that way. Okay, is it clear now?
Yes, sir.
All right.